Thank you all for joining us today. I want to welcome you to TRC's UN Edge Conversion Phase webinar. I'm Ben Dwinell, Director of Solution Architecture here at TRC. I'm going to be joined today by Tommy Acers, Mike Emanuel, and Graham Blakey. We're going to start today's webinar with a review of our four-phase approach to UN migration success. For those of you who haven't attended the previous webinars in our four-part series, we'll do a quick review just to cover the key components of our strategy. Then we'll go into the specifics of our conversion phase and strategy and the activities related. Excited today because Tommy, Mike, and Graham are really going to dive in deep details to focus on specifics related to electric, gas, and water commodities as it relates to your UN conversion. We'll finish up by taking some of your questions. And, as you think of questions, please type them into the LinkedIn live message board. So I guess with all that, we'll just dive in. I thought we'd just start before we get into any of our conversion phase stuff. Just give you all some background about TRC and our experience with Esri platforms, enterprise GIS implementations, and specifically, utility network migrations. So, we've been executing UN migrations for the last 8 years. With our first go live in 2018 at National Grid. We've been Esri Platinum partners for 12 years. Completed 14 utility network go lives across electric, gas, and water utilities. We've got 8 utility network migrations currently in flight. And lastly, we have Esri specialty designations in utility network management, cloud implementation services, software and system release and readiness, ArcGIS Online, and state and local government. So over the last 8 years of executing UN projects with our clients, we've collected all of our experience into our best practices plan. And this really helps with planning and executing a UN project. And we've compiled this into two clear components that we use for UN accelerators. One is our UN strategy. This is our best practices in planning and executing a successful UN migration, and we structure it into 4 distinct phases. Secondly, we've also developed a tool set that automates many aspects of your utility network migration to accelerate your UN migration projects and make your delivery more reliable with a higher set of data, higher quality set of data. So the TRC's UN Edge program is really a 4-phase strategy for UN migration success. And, we've developed this strategy, as I mentioned, over the last 8 years, and it's a combination of best practices, techniques, strategies, automated tools that help our project teams and client organizations migrate to the UN efficiently, with precision, and with a high rate of delivery reliability. We've separated into 4 phases so that it can be executed collectively as independent phases of a long-term project, or you could execute them sequentially as independent project schedules. And this really allows you to separate, potentially maybe the assessment phase from the remaining 3 phases so that you and your organization can get ahead of things like data remediation, infrastructure adjustments, and integrations to support the new requirements with deploying the utility network. After today's webinar, we'll follow up via email, and we'll send you links to our YouTube sessions for phase 1 UN assessment, as well as our phase 2 pre-conversion webinar. So just a quick review of our pre-conversion activities, and we're going to be focusing today on our conversion activities, which is really getting you from your legacy system to your production environment. Now, once you're at this point, you've already executed an assessment and you've gone through pre-conversion activities such as detailed schema mapping, You've already started or in the midst of your data remediation and cleanup and preparation for the UN, and you've likely run one or more pilot conversions at this point. And when I think about the pre-conversion phase, one activity that often gets overlooked but is extremely important is finalizing your UN release strategy. And this will align your UN release with your organizational IT and other system upgrade schedules. It will support defining your release strategy as either cut over parallel systems or a phased release. And this is a very important decision as it will affect very key technical and architectural decisions about your data and your solution deployment. The accelerators that we have built up over the last 8 years is our CARMEN toolset. And CARMEN stands for Configurable Advanced Rapid Migration Engine. And it is our FME-based UN automation framework that accelerates many of the tasks and aspects of your UN migration, from data cleanup to data conversion to your UN build processes or to your lengthy deployment steps. Having automation to accelerate those phases really improves your delivery reliability, reduces overhead on your teams, and the project schedule by automating large portions of this processing, the data builds, the UN builds, and cleanup activities. All right, let's dive into conversion phase. So I'm going to talk about really 4 key areas that I'll reference today that, if planned and executed correctly, can improve the quality of your data conversion and the quality of your system migration to the utility network. I'll cover these areas in using templates and standards where possible, being intentional about applying automation and accelerators to be efficient during your project, focusing on quality and efficiency throughout the process from start to finish. And then lastly, getting ahead of your key UN build considerations that will set you up for meeting your business critical requirements and for adding future functionality. So a key factor for success during your conversion is staying aligned with templates and industry standards where possible. From our experience executing many UN projects, a lot of redesign and rework during the conversion phase originates from a misalignment of organizational requirements or technical specifications or following industry standards. So some areas we can hit is, thinking about your data modeling efforts. We're going to want to use templates where we can to gain efficiencies and stay aligned. Look at Esri's Essentials model or the full data model and find the right starting point for your organization and for your requirements. You can focus your modeling efforts around your key driving factors, such as regulatory reporting or key functionality, such as tracing or subnetwork exports to support your integrations. You're going to want to use your Esri and hosting platform recommendations for architecture, infrastructure, and system sizing as a starting point to save time. You can focus your system design to capitalize on your organization's capabilities and technologies to maximize your built-in support and investments. You're going to want to apply key pattern and protocol requirements for the UN. A good example of this is switching all of your data connections over to your API-driven protocols. That's a major transition for the utility network, and something that has to be focused on from the start of your assessment through your planning, through your design, and into your conversion phase. Want to align your security strategy around your organizational standards and policies. Design your user access and edit control strategy on what's supported by the UN out of the gates. We're moving all of that security and fine-grained edit controls from the data tier and typical legacy enterprise systems out to the web and portal tier. So getting ahead of those things can certainly be a big factor. Going to want to apply industry standard exchange formats as you approach your integration planning, and adopt standard protocols where possible. And this will really simplify your integrations for more adaptability across more systems and opportunities to consolidate within your integration tier. And lastly, I'll just point out, prioritize your data conversion modeling and configuration elements that are required for your business critical functionality. I'm not going to go into depth on this point because Mike, Tommy, and Graham are going to cover this in detail for their specific commodities. But what we have found is it's significantly more costly in terms of time, schedule, and resources to make those major adjustments about data scheme, attributes, UN rules, domains, configuration settings during your conversion phase than addressing it in the previous phases of the migration journey. So on the right side of the slide here, I've listed, a handful of the most time-consuming and labor-intensive activities that you're going to face during your UN conversion. Key to executing your conversion efficiently and with reliability is taking advantage of accelerators and automation within each step of the process. Firstly, you want to have a conversion tool to support your data and system conversion that automates the movement of your data from your legacy systems to your UN data instances. This is going to improve your data quality, the quality of your conversion, and allow rapid and iterative data migrations. Secondly, you're going to want to consider a conversion tool that automates many of your data transformation or data cleanup tasks. From our experience, a large percentage of your UN data error fixes can be automated, such as geometry errors, stack points, missing junctions. These can all be automated. And so this is going to significantly reduce manual efforts and your time to release. And again, improve your overall data quality at the point of release. Take advantage of using, Python scripts, GP tools, FME, and other tools for automation to speed up your build process and your build steps after you've migrated your data. There's many steps post-data migration that can be automated to gain process efficiency and reliability in your execution. After you've converted your data, you've loaded it, you've built the UN, now invest in your DevOps tools to automate your deployment steps. We can automate the process of moving your data instances, promoting your map and feature services to test and production environments, web maps, pro projects, web applications. There's a high volume of deployable elements related to a UN project and migration. So take advantage of your DevOps tools to automate those steps and streamline all of these processes. And lastly, early on, be efficient with your testing. Identify and implement automated testing suites to support a higher data quality, a better tested application and configuration out of the gates on your release. Third thing that we really focus on as part of conversion is quality assurance. What steps can we take during the conversion to improve quality of your data and the quality of the conversion overall? As we just discussed, embrace your automation and your accelerators. This is going to increase the volume of fixes in shorter time periods, leading to that higher data quality. It'll also reduce the chance for human errors in your deployment steps by automating the execution. We typically apply industry standard reporting tools to pre-classify error types and counts into organized reports that are easy to ingest. And this is really going to allow more time for your teams spent fixing issues rather than organizing and filtering through them. You want to execute iterative data migrations during your conversion phase. This is going to increase the volume of your data configurations, data and configuration issues that you can catch. And just gives you the opportunity to identify and fix more issues as you ramp up to your release. We recommend running at least 2 release dress rehearsals prior to your UN release during the conversion phase. This is really to refine your cutover steps, improve the delivery reliability, and also reduce your cutover duration and shorten that system outage time for your release. Lastly, as a quality assurance activity, run a separate testing activity for data acceptance. Very important that there's focus on the quality of the data that goes beyond just user-facing workflows or end-to-end testing cycles. Couple that with having a data governance board that encompasses your key stakeholders, so you can quickly agree on changes, approve schema adjustments, or data remediation steps that need to happen prior to your release. Finally, when planning your UN migration, what factors provide the best chance for success on your release? I'll continue to point out and focus on the prioritization and focus on your business critical capabilities for that first production release. Have a plan in place to add additional capabilities during the second or third or fourth release cycle, but really focus on that business critical capability for your first release. Consider your cutover execution when you're defining your UN strategy or your UN release strategy. This gets overlooked often. However, it may be appealing to do a direct cutover of all of your data. However, when you start executing your dress rehearsals and your iterative conversions, you can realize that this can take time. The complexity of your integrations may extend your cutover duration for a long period of time. And so think about the execution of your cutover strategy as you're planning how you're going to do your UN release. It really does impact things such as your data architecture, service architecture, and your overall release plan. Each organization that we work with has unique systems, data policies, requirements, and we can learn from those. However, we have to tailor all that we've done in the past for the specific needs of each organization. So be cautious to follow too closely a release strategy that maybe worked with another organization. Implement a good strategy for continuous improvement and continuous delivery. This reduces the strain on your first cutover if you know you have a second and third and fourth release coming to add capabilities slowly and steadily, getting more and more value out of your UN migration. Lastly, have a clear roadmap for that post-migration release. You may want to improve other processes within your organization that interact with your GIS system. You may want to add additional business capabilities, inspection workflows, design. Plan these advancements ahead of time so you know when they're coming. And again, this reduces overall strain and stress and risk on your initial cutover. Great. So at this point, I'm going to hand it over to Mike so he can talk about electric UN considerations.
Good morning. My name is Mike Emanuel. I'm a solution engineering team lead here at TRC. I've been working in the electric utility space for the last 10 years, 8 with a utility going through its own UN migration, as well as the last 2 with a large small world to UN migration. Next slide, please. So at the point that we're coming into the conversion, we are looking at, you have made your model decisions. While I'm waiting for the slide to move
Sorry,
forward.
Mike, I'm frozen for a second.
One of the things to consider after you've made your model decisions, which you have made it based on the tools that you are implementing, as well as going with a high fidelity or low fidelity. Now you're looking at your own internal needs. Consider your spatial data requirements internally. For example, inside a vault, do you track exactly where equipment is placed, or do you simply put it in the vault? Pads, do you track where equipment is placed on a pad? Pads when it's large enough to have multiple equipment, or do you do it off basically placing all of it on a single pad? Things of that nature. Attribute data requirements. You will have different internal requirement needs than what the UN has, and it is designed to handle that flexibility, so do not be afraid to expand it. Metadata requirements. This is a big one generally with regards to the field. You have dates relative to the UN, such as when the feature is created in the UN, but that doesn't necessarily represent when a feature is installed in the field. And that may be something you want to capture, and you want to consider those types of attribution changes with regards to metadata. Terminal configurations. Are the terminals set up for the devices you're deploying in a manner that you would use or your ADMS would use? Do you need a four-way switch? It's going to have more than two terminals on it. Your transformers, do you go simple high-low, or are you looking at bushings? Finally, as I've already mentioned, always consider your internal workflows. Part of the success of your system is if it can be adopted internally within your company. It is the field work that is going to verify what is coming through from the office side, and it is the office side that will provide the information to feed to the field. Next slide, please, Ben. One thing to consider is the fact that your GIS is a system of record. Your goal is generally to represent what is in the field, but you are also faced with the realization and reality that you are representing what is coming, proposed features, construction. There is always activity going on in your system, as well as what has changed. And there's a certain lag that occurs from the time something is actually changed in the field till it hits your GIS. And this is where adding a secondary status, in this case, we're going to use construction status, comes into play. So you have life cycle status. This is a built-in field to the UN. It is used by the UN. Esri does not recommend making changes to it, so there are limited options with it, proposed being one of the options. But in addition to that, you may want to add additional construction status via another field. This one allows you the flexibility to meet what are your own internal requirements, especially with regards to fields, so that you can say, is something going to be removed? Is something going to be added? This allows you to have that flexibility and maintain all that information within your GIS to meet other needs. Please, next slide, please, Ben. Finally, and this is the big one, your GIS and how does it interact with the various systems that exist within your organization. Whenever looking at other tools, first thing you should consider, is there a utility network API? More and more tools are including that. They can read either the JSON files that are being exported when you do a subnetwork export, or they can read directly from the GIS itself. You have to consider your connectivity model considerations. The UN has its own connectivity. It traces out based on its perceived flow of electricity. You have other systems that are more of a model, a connected model consideration. And so you have to consider those differences. Are you going to include proposed features within your system? This is a big one for SCADA, and that is possible to do. How are you going to handle de-energized features? Your ADMSs, your OMSs, all like to know what is available to be used, even if it is de-energized. So, and there are strategies for handling that as well. And finally, elbows are always a big deal. Do you have enough of them? Are they on your transformers? Are they on your load break junctions? Things of that nature. Finally, your integration with other systems. Do you have planning software assigned so that your distribution planning, your transmission planning can use the data from the GIS? Do you have distribution design systems? These can all be integrated with your GIS. They can feed back and forth, and finally your work order management system, which may not be your final, it may be your primary. With that, I'm going to hand it over to Tommy to cover gas. Thank you very much.
Sorry about that. There we go. Got the video going. Thanks, Mike. Hello, everybody. Good morning, good afternoon. Tommy Acers here. As a business architect, I have a horizontal role on our utility network projects, balancing technology with the various business processes and roles involved. My utility experience reaches back nearly 25 years, with 15 years of it being heavily focused on GIS, both as a GIS manager at gas and water utilities and as a consultant for the better part of the last 7 years, where I've assisted with a number of gas and electric utility network migrations. Over the next couple of slides, I'll highlight a few topics that may require a little extra attention during your utility network migration project. Next slide, Ben. So let's start with something simple. Naming conventions. Now, this goes a step further than the initial mapping of features from your source data to the utility network equivalent. Specifically, I'm referring to the subnetwork controllers. For those of you that aren't familiar with that term, just know that these are the special devices that represent the source or starting point for each subnetwork. For example, operating regulators are for the pressure subnetworks and emergency valves for your isolation subnetworks. Configuration of these subnetwork controllers requires each device to be given a unique name. Now, this is different than your asset ID from an asset management system. Instead, this can just simply be a descriptor. Just remember, it has to be unique across all of your subnetwork controller names. Also, it is at the subnetwork controller level where your subnetwork names are defined. So you'll need both of them up front. Now, the subnetwork name value is systematically propagated to all UN features downstream, so it doesn't need to be manually maintained beyond the initial subnetwork controller configuration. So when you look at the tables to the right, the subnetwork controllers table is a table used during conversion. It can be updated and iterated on during each of your data mocks, but this does not live past conversion time. After conversion, once the subnetworks are generated, you can see on the other table how the pressure subnetwork name is unique per row, and the controller names are concatenated to a single value. So bonus considerations you can see on this table are the summary columns highlighted in green. Now, these examples are the specific columns included in the out-of-the-box schema from Esri, but other metrics can be configured. Now, the projects we've executed, we can say it's pretty common for utilities to already have pressure system names defined. Some have isolation and cathodic protection subnetwork names already available. Now, having the system subnetwork names has been the least common. This isn't a huge lift, though, when you can easily visualize system subnetworks kind of at the town or city level. So just include the city name, and you're probably going to be good to go. As long as you remain uniqueness for every tier, you're fine. Now, a quick comment on cathodic protection subnetworks. We've experienced a wide range of usage of CP systems that go live, from clients who just have test points to others who have data available to completely build out the cathodic protection subnetworks, including inspection processes. So just note that a full build out isn't required for the utility network to function. Don't fret if you don't have the data now at this time to build it out. Just tackle it later in a post go live activity planned out, like Ben has mentioned previously. One more naming convention to consider. For our transmission operators moving over to the ArcGIS pipeline referencing toolset, be aware that you may have to adjust or create route names. Depending on your previous linear referencing solution, there could be some differences, like requirements around unique names for every continuous segment. And here's one last thought before we move on. Please be mindful of how these names will be generated and maintained in the future. At some point, a GIS tech will have to be provided that information for subnetwork controller configuration, right? Now, this may not be the case today, so from a business process perspective, please just consider it. Next slide, Ben. Now, focusing on data, I'd like to frame this into two categories of remediation and enhancements. Now, with remediation, I consider these to be items which are inhibiting our ability to have a functioning utility network, or those that are limiting our spatial analysis capabilities. So with that in mind, an age-old data issue that we still continue to encounter is disconnected features. For our gas industry, we continue to heavily rely on geometric coincidence to determine connectivity. So solving for these undershoots and overshoots is a must. Now, there is automated logic that can be applied during conversion within our CARMEN toolset. Just be aware that this may increase your time and effort for validating the migration. Alternatively, you still may choose to take a manual approach and either resolve them pre or post migration. And Ben touched on this earlier with some utility network errors. We regularly generate junctions to resolve common errors, such as where T's aren't shown to connect two mains. We didn't have to do this in the past, but now we do, particularly for those situations where mains are of different asset types. Of all the topics I discussed today, conflation is likely the biggest effort. Now, as a reminder, the purpose of conflation is to create a more accurate, comprehensive representation of your gas system and not necessarily resulting in exact real-world location. This gets you to a point where you can utilize your third-party data, such as demographic data, parcel data, basically anything available on Esri's Living Atlas. Now, ideally, you've determined your plan during the assessment phase, but regardless, it's worth revisiting at this time. This is definitely one effort that I'd prefer to have accomplished before go live. Having this completed in the source system is great, but it's not always feasible. So if running these projects in parallel is digestible, this shifting process can be incorporated into our CARMEN toolset. This does result in more processing time and likely additional QA effort, but the payoff is that it's the least disruptive to your editors and end users. Enhancements, on the other hand, these may be considered nice to haves, meaning we have a functioning utility network and accounted for all business requirements, nothing to really prevent us from putting this into production. But we're going to use this opportunity to incorporate a deeper level of detail into our GIS data. Two such opportunities we regularly encounter are with regulator stations and service lines. With service lines, it's overwhelmingly that we hear utilities would like to have them represented in GIS. After all, it is visually appealing, but it's also the most direct way to execute an outage trace and generate a list of customers. Unless you're one of those utilities that has already altered your business processes to have GIS become the system of record for this information, a conversion project is the perfect opportunity to initiate that change. Whether it happens during the project or post go live, it's very likely that you have enough information tabularly stored in another business system that can be fed into one of our CARMEN tools and have these service lines generated. With regulator stations, it's common for there to be a single point depicting these locations in your source system. These tend to functionally represent operating regulators, those subnetwork controllers for the pressure subnetworks. While it's not functionally necessary, there is a big value add for us to take that single point and depict the additional details such as bypass valves, heaters, odorizers, and fittings. If the data is available from an asset management system, template station layouts can be utilized to create detailed regulator stations within our CARMEN tools. Alternatively, if you'd like to generate this detail uniquely per station, you may want to engage with our partner GeoCam to begin a station modeling activity where they can come on site and generate 360-degree imagery and 3D point clouds, creating those images that you see there to the right. Now, as a byproduct of this, a feature extraction process can be run and generate utility network ready features. Before we move on to the next slide, I'd like to note that when it comes to data quality completeness of a subnetwork, here on the gas side, we do have a bit more flexibility than Mike mentioned on the electric side. We're not as tightly coupled with ADMSs or OMSs, so we can go live with some disconnected features. I mean, if you live with them today, then we're not really removing any existing capability. We can bucket that effort and scope it for a post-go live activity. The important thing here is to have a plan to get there, especially as our downstream applications, such as DNV Synergy Hydraulics, will begin to rely on cleanly built subnetworks to generate their models. And of course, we're always looking for ways to enhance our risk analysis models. With that, we'll move on to the next slide, Ben. Another side goal of GIS here is to be the source of information about everything for everybody. All right, well, at least be the primary source for supporting the yearly PHMSA reports and central access point for your TBC documentation. And please note that the UPDM does come with some columns looking to store those qualifying TBC attributes, a few of them shown here in the middle. The UPDM also supports inline inspection readings and ranges, as well as direct assessment data. Having all of the data here means it can easily be integrated with your risk management software. Now, having the attributes in GIS isn't enough. We know this. So having a link back to the supporting documentation is needed. So consider how your documents will be stored. Hopefully they're in a searchable document management system. Ultimately, the ideal is to have it standardized. Once standardized, a determination on the need for additional attributes in GIS to store other links or attributes can be made. As for those yearly reports, by now I'm sure you're aware that the UPDM has enough attributes around your leak and pipeline data to support those PHMSA reports. So we tend to have to focus on getting the business processes aligned for the data to be entered into GIS and maintained there. Hopefully I've covered enough topics to get you thinking about your GIS or your gas utility network migration project. With that, I'll pass it over to Graham to talk about water.
Hey, thanks, Tommy. Good morning, good afternoon, good evening, everyone. I'm Graham Blakey. I'm a GIS solution architect in the TRC Europe team, and I'm based in London. I have 25 years plus experience in geospatial and GIS, largely with the ArcGIS platform, and 7 or 8 of which have been spent directly in the water industry. So today I'm just going to give you a quick whistle-stop tour of some of the key considerations when undertaking a water utility network conversion. Next slide, please, Ben. Okay, so this is a typical UN migration activities slide. It's a summary, really, of the end-to-end UN deployment process. Those of you that have been involved in any kind of project deployment will certainly recognise the kind of phases we've got across the top there. But I include this slide mainly for reference here. As you can see, there's a lot on there, but in the interest of time, I'm not going to go through each and every process, but I would like to draw your attention to just a few key activities that relate to the conversion phase. So starting over on the left in the UN migration activity swim lane, we've got the data audit piece, and that would typically be done as part of the preparatory work. That directly feeds into that data readiness report we've got down the bottom there. And then as we move into the POC pilot kind of phase, we have data triage and prototyping, which I'll talk a bit more on later. And this typically comprises of multiple cycles and iterations, kind of as Ben highlighted earlier. And then this in turn will inform our UN release plan, again, which is typically comprised of multiple cutovers. Next slide, please, Ben. Okay, so here in the top right corner is an example of a data audit readiness report. We have the issues listed and we have them quantified. Those numbers there, this is a fictitious water company, but those numbers there are quite realistic in terms of the kind of volume. So don't be scared by kind of large numbers against those kind of issues. It's common across many organisations. But the key attributes I'd really like to kind of home in on are the business value and the UN value or criticality ones we've got there. We would typically assign these working with a client, and they would be used to support a prioritised data remediation and cleanse strategy. Now, in terms of data remediation, there are typically kind of 3 complementary approaches we would take to data remediation. The first one there is fixing source, which could be in a non-GIS database or application, or indeed fix at source. And the first example I've got below there in the diagram shows a typical kind of either fix in source or indeed at source issue on the wastewater side of the business. This example shows a complex wastewater chamber that includes a combined sewer outflow overflow. Now, this type of chamber is common to many sewer systems, particularly here in the UK, where many such systems are 100, 150 years plus old. In many cases, the data we require for the UN may not exist or may be incomplete or unreliable. On this diagram there, you may just be able to see I've highlighted the depth values, for example, within the chamber, which we'll need in order to make those reliable associations and then hence enable tracing further down the line. So this example, it kind of illustrates a key readiness challenge we often see with UN conversions, the requirement for asset-related Z-value data, which legacy data models do not necessarily require. Now, you may be able to fix this type of issue at source in your design and build databases, for example, or you may be able to extract this data from original hard copy drawings, squirreled away in a plan chest somewhere, or you may not have them at all, in which case your only option may be to fix them at source via site inspection or survey. But as Tommy said earlier, fear not, these issues can be resolved as we go through that process we just looked at in the slide before, and indeed post kind of initial release. The other one we typically use is fix during migration, and this is very much where CARMEN comes in to kind of handle the automated fixes that we can apply during that migration process. But just be aware there are also likely to be some manual fixes required as well. And then thirdly, fixing the UN post initial deployment. This is something not to be afraid of and is common for most, if not all, migrations. Ben mentions this as part of his kind of continuous improvement as part of your UN release strategy. But just be aware that post-deployment fixes may require some configuration and design changes, depending on kind of how deep we've been able to identify them and design for them back in the original stages. But in practice, all three of those approaches are likely to be required. Okay, so the kind of final bullet I've got on there is I just wanted to highlight one or two of the kind of common, high value, high impact water related data issues. The first one of those, and probably isn't exclusive to water by any means, but is a very common one typically with water companies, is that missing connectivity at site. It's common for water utilities not to have the logical connection data in their current GIS that represent the flows of water into and out of site. This will prevent a network trace from continuing out from or into that site and would leave other parts of the network essentially isolated. This will need to be fixed and is likely to require further investigation in order to resolve. And one thing I would also highlight here is for these kind of fixes and these kind of edits you're making to your network data, just remember to plan for these as you make these edits and you migrate to the UN. Ben mentioned DevOps earlier about that kind of route to live. In resolving missing data issues like this, for example, you are likely to be adding to your pipe assets. You can see there in the example there. My pipes in some cases are stopping well short of the site itself. Now, those additions and those changes could, if there are enough of them, and often there are, change some of your key reporting stats, your regulatory requirements, your KPIs, and indeed, this may impact your regulatory reporting. If all of a sudden you're reporting 3 or 4 extra kilometres of trunk mains across your organisation, for example. And then the second one there I've highlighted is incorrect district meter and outlet terminals. Tommy explained to us kind of what sub-network controllers do and the vital role they play in the UN. Well, district meters on the water side are an important feature of the UN. They are sub-network controllers for the district meter areas. Each one should have an inlet and an outlet terminal. However, in this example, we have 2 outlet pipes flowing from a single district meter. In most cases, an automated fix can be applied using a combination of the district meter ID, the asset ID of both of the pipes, and then matching those against the district meter area facility ID and the DMA feed meter IDs, for example. When a match is found, the pipe should be connected to the outlet. And when no match is connected to the inlet, the assumption here being that where a pipe is not serving another DMA before entering that district meter. So just a couple of examples there. There are many, many more. I've only got a few on that list as well, but just wanted to kind of highlight a couple of the key ones. Next slide, please, Ben. Okay, so I think we've already touched upon schema mapping, but as with any data migration, schema mapping from source to target is a critical activity. The complexity of it will vary from organisation to organisation. But in many cases, certainly within a water migration, our experience tells us that this will require substantial effort and input from a broad range of subject matter experts across your organisation, typically involving many workshops, many discussions, differences of opinions, potential kind of arm wrestles, and compromises will undoubtedly need to be made. So be prepared for those. Now, in terms of kind of the migration, we, as Ben was saying earlier, we advocate at least 1 or 2 pilot migrations, and indeed in terms of our kind of final release, we would tend to do that as well in 2 or 3 or more release patterns. You have various kind of options in the water world, I would say. Typically, companies may elect to convert their water network first, potentially followed by wastewater. Some may even choose not to convert their wastewater. Some companies may even not be responsible for the wastewater in their area. So very much kind of varies organisation by organisation. You may have specific water pressure zones, district meter areas, catchments, etc., that lend themselves to a pilot migration. And then another one I just want to highlight there, and an increasingly popular approach we're seeing, is to migrate to the recently released Essentials UN data model. Ben mentioned it earlier. Essentials is effectively a significantly trimmed down UN data model. So I've got the numbers there in that table, but as an example, in water and wastewater, there is a 90% reduction in the connectivity rules you need to deploy the Essentials model, and a 60 to 70% reduction in asset types. So significant reductions there. However, with these reductions come reduced capabilities. So whilst we are seeing many clients electing to take this approach, and certainly some of the clients we've spoken to in the UK have found the traditional, or what is now termed the expanded data model, a real barrier to migration. Essentials is an attractive option, but there is a demand to add to that, and at different points through that deployment process. So in response to that, here at TRC, we're currently pulling together kind of a hybrid approach. Think of it as an Essentials Plus kind of model, and this consists of kind of bundles of connectivity rules, asset types, associations, custom relationships, etc., that would provide additional bespoke capability for a water company, which typically would be deployed incrementally post go live. I recently bumped into a former water company colleague of mine at the Esri UK annual conference, and having recently deployed the UN at the organisation he was working at, his advice was, press ahead with your migration and deployment for the UN, get it out there, but then add to it, fix it, enhance it once you're into production. So kind of messages I think we've heard throughout the webinar today. And then just a final point, for any more information on the Essentials data model, I've popped a link in there to a recent TRC blog post on the subject. And of course, there's a vast array of Esri documentation on the UN. Thank you. And back to you, Ben.
Great. Thank you, Graham. Let's go ahead and plan to take a few questions here as I try to get the slide moved for us here. Here we go. So we got a few questions here that I'll throw out there. I think I've got at least one for each of the commodities, so I think that works out great. The first question is for Mike on electric UN. If my asset group and asset types, if the asset group asset types provided with the UN do not match what we call our equipment. For example, a capacitor is called a power factoring equipment. Can we change the names of the asset groups?
So the UN has a little quirk in it, and that is the fact that the network rules are based on the names of the asset groups and the asset types, not on the domain numbers. So your best bet is, first off, you should never change the names. That will cause you network rule issues. I cannot emphasize enough, don't change names. What you should do is consider adding a potential asset group, asset type if necessary. Work with the ones that are there as much as possible because those are with the out of the box rules. But if you do add one, which you may want to due to business needs, you are going to have to step back and readjust the network rules appropriate for those devices that you add. Ben?
Great, thanks, Mike. Yeah, great answer. Great. Let's move on here. Next question is for, let's see, for Tommy. Do you find most gas utilities already have the asset detail they need, or is there a lot of data you wish you had?
Yeah, that's a great question. I think I hinted at it a little bit in my slides that generally, I think utilities have more than enough data to definitely get started, and probably even enough to enhance some of their data, like at regulator stations. The hurdle truly ends up being where is it? It'd be meaning that it's not available in GIS as features. So that means the hurdle you encounter comes with A, getting it migrated, but B, the biggest heavy lift is reworking all of your workflows and your business processes to make sure that the information will continue to get over to those GIS analysts for data entry and validation with the rest of the utility network features. This is where you really start to dive into integrations with your asset management systems. Probably a topic for a whole other webinar. But all in all, I think utilities tend to have the data available. It's just not yet consolidated in GIS.
Great, thanks, Tommy. Yeah, it's there's a ton. I would agree with you that there's so many opportunities to advance your data completeness as you head into the higher fidelity model, more complete model, but where does it live in finding it, right? It can be all over your organization in different systems, or maybe it needs to be generated. So it's certainly a consideration to add to your data readiness as part of an assessment.
Yeah, absolutely. And just an aside from that, like bringing all of that data and realigning your workflows, those aren't sexy projects or sexy conversations to have. It's not artificial intelligence redoing some fancy analytical thing for you, but the payoff is huge, right? You've consolidated your workforce and your data entry onto a couple of applications, and your process has become more and more consistent. So it is effort that to make that happen, but the payoff is huge. So I'd highly recommend people consider updating their business processes and leaning more onto GIS as that repository for all of your data.
Great. Thanks, Tommy. That was a good add in there.
Absolutely.
Great. So great. Next question is for Graham. And I think hitting on your final point there, Graham, this question comes in. When starting with the essentials model, how do you know when it's time to grow into a more advanced water data model?
Yes, no, good question. Probably ideally, I would say, as far to the left-hand side of my kind of activities slide as possible. So really, you should be aiming to identify what capability over and above essentials your organization needs, and when. So, for example, for a couple of clients, I think we typically looked at things like, certainly on the water side, I think kind of the customer supply type, things like residential versus industrial, for example. And I think, also things like adding operational tables as relationships. And sometimes that can be things that it can be tables that even the expanded model doesn't necessarily cater for. So, we'd be building those custom relationships for specific operational tables. So it really does vary from organization to organization. But I think the key point is, as early as possible and kind of as part of your UN release plan, kind of identify those and build them into the plan.
Yeah, Graham, I'll just say, I like the way it's not a one size fits all, the way you describe it. it's organization to organization. And if you're starting with that essentials model, are there a few key specific assets or areas of your model that you need to go more high fidelity to get to that release point to support your business critical workflows? Those are activities that we typically will identify during design and during pre-migration, where we're iterating through data and understanding what exactly has to be in place, what has to be configured, what rules have to be there for data integrity to support those business critical functions.
Exactly. And I think kind of pre-essentials, we were in a world where we were starting with the expanded, the full model, and a lot of time was being invested with some organizations in terms of stripping stuff out and hiding fields and attributes. Yeah, I think it's certainly preferential to kind of start the other way and then build incrementally.
Great. Well, thank you, Graham. I think those were all really great questions. So appreciate the feedback and great responses. So thank you. All right. So let's see if I can get to my next. So I want to talk a little bit about TRC's UN migration playbook. It's something we've been working on here this spring. And just want to let you know, everyone attending today's webinar is going to receive an early access to our UN migration playbook. Now, this is a resource that we've built from our real world implementations to support your migration planning, deployment, and optimization activities. Just wanted to give you a heads up on that. You can expect it in your inbox shortly after the holiday. We really do look forward to, sharing this with you very, very soon. Great. And lastly, just want to say, thank you all for attending our UN Edge Phase 3 conversion webinar. Also let you know that our next webinar will be on Phase 4 post-migration and getting into that continuous improvement, continuous delivery model with UN data, UN rule base, and other key aspects of your migration. That will be coming in August. Between now and then, please feel free to reach out and contact any of us with any follow-up questions or comments. And just a reminder, links to part 1 and part 2 of this webinar series will also be emailed out. In addition, this has been recorded, this webinar today, and we'll send the link to this recorded video as part of that communication as well, so you can share with colleagues. We really look forward to seeing all of you at either an upcoming conference or the next webinar, and thank you again for attending. Have a great day.